Okay, we are back. Can someone confirm that you can hear me? Okay, Mr. Wu says you can hear me, so all good. So I've just spotted a small mistake that I made in one of the solutions that I showed you. So I'll fix that and I will post a solution, a proper detailed solution. It's got to do with the sum of a divergent and convergent series, right? But I'll explain the details in something I will post for you to have a look at. Okay, I've also been thinking about Mr. Nike's question, and it seems to me an easier way to tackle it is to say, Mr. Nike, if you've got a specific question, if you've got, a particular tutorial that asks that kind of question, maybe let me know that one, then I can write out the solution for that the way I expect it, show you where the marks are, and then post that. I think that's probably a little easier, definitely for me, than trying to come up with a question. Okay. For the rest of the session, I thought maybe I should let you guys ask questions. It can be about the test, the format of the test. It can be about actual tutorial problems for the last week, for what's still coming. Any questions, it's over to you. Unless if you don't have, then I'll show you more examples of things the way I want things written out. It's all quiet, which means let me start then by showing you the mistake that I made in the thing that I showed you last. There. So where's the mistake? Well, the mistake is over here. I don't know if you can see the hand. You should, right? You can see the entire screen. That's a mistake there, right? The reality is we know that that converges. And so we don't need this step here. We can go straight to this is equal to this plus this, because since this converges and this converges, the sum converges, and that means that converges. So the mistake is we don't actually need this bit here where the hand is showing now. I'll write it out properly and post the solution. And maybe in this one, I'll show you as well how the marks go. Okay? I'm going to stop sharing because I can hear a question coming in. Please do question 74 from chapter 11.1. Let's have a look at what that question is. So it says, please do question 74 from chapter 11.1. So AN is equal to 1 minus n divided by 2 plus n. And it says determine whether the sequence is increasing, decreasing, or not monotonic. Is the sequence bounded? Okay, so while I do this, let's see if I can test how the writing works on this interface without my little writing device. Let's see what my writing looks like using my mouse. It's probably not going to be very nice, but let's try it. So AN an is equal to, so I suppose we can go through how I reason through it as well. An is 1 minus n divided by 2 plus n. 2 plus n. All right. Now, let's calculate a few values and see what it looks like, right? Because that might show us a pattern. And so A1 is going to be 1 minus 1 divided by 2 plus 1. And that's going to be 0. 0 divided by 3, which is 0. Oh, A2 is equal to, it's going to be 1 minus 2 divided by 2 plus 2. And this is going to be minus 1 over 4, it's minus a quarter. A3 is going to be, okay, so we can immediately see the numerator will always be negative, right? The numerator will always be negative after the first term. So now it's going to be minus 2 divided by 5. A4 is going to be A4 is going to be minus 3 divided by 6. That's a half, negative a half. Are these getting smaller or larger? So negative a quarter, negative 2/5, negative a half. To me, it looks like they're getting smaller, right? A5 is equal to minus 4 divided by 7. Minus 4 divided by 7. That's smaller, right, than a half. Negative a half would be minus 3.5 divided by 7. So it's still getting smaller. So the question is it bounded below? Is it bounded above? Is it bounded below? It's bounded above by 0, because this number will always be negative. So there we've got one of our answers. It's bounded above. Is it bounded below? Can this ever be larger than negative 1? To me, it seems as if the numbers will always be larger than negative 1. Can we prove that? So we want to show two things. We want to show that 1 minus n divided by 2 plus n is greater than or equal to negative 1. Right. Now, This is going to be the case if and only if I can cross multiply, right? So I can say this is the same as that divided by 1. There's an idea coming in. Can we use limits to determine if it's bounded or not? The limit as n approaches infinity. The limit as n approaches infinity. Maybe, SP Temba, you can give us some more details. Let's see how this goes first, though. So we can write the thing on the right as -1 divided by 1, right? So we want to know whether 1 minus n divided by 2 plus n, Malobolo, no, you can't do that. So what we did on the left here was to just get an idea of what's happening. It's not it's not considered part of the argument. So we need to be careful here now. If we want to know if 1 minus n divided by 2 plus n is greater than or equal to -1, then it means the numerator here is always positive, right? Sorry, the denominator is always positive. So that means I can multiply both sides by the denominator. So this is so if and only if 1 minus n is greater than or equal to -1 times 2 plus n. Right. And this is so if and only if 1 minus n greater than or equal to -2 minus n. Is that correct? And this is so if and only if 1 is greater than -2. And we're done. Is that okay? So what have we shown? We've shown that the sequence is bounded below by -1. I know my writing is not great, but I think you can make that out. Let's double check. So we said we want to show that 1 minus n divided by 2 plus n is greater than or equal to -1. We don't need this one here. Let me remove it. Oh no! Oh no, I've just removed it. There's no undo here. Okay, I hope you saw that. Okay, let's go back to the question. So we've shown, I hope everyone saw that. So what we've done is we've shown that it is bounded between 0 above and -1 below. And our AN again looks like this. So we can rewrite what we had quickly. AN is equal to 1 minus n divided by 2 plus n. Okay, so bounded above by 0, bounded below by -1. Let's have a look at the questions. So when is 0, the limit of the sequence is -1. This is my mistake, but it could still hold that it's bounded. Yes, it is bounded between 0 and -1. Okay. Yes, so what CK Wu is doing is you're calculating the limit, right? So we wanted to show if the sequence is bounded. Now we also want to know whether it's increasing or decreasing. So that's the next thing. Bounded above by 0, bounded below by. Can we show that it's decreasing? Because that's what we think, right? It starts at 0 and it decreases. And so we think it's decreasing. And so we want to increase in and show that the sequence decreases. So what we want to show is show that one, it's decreasing, right? So show that. How do you erase? Show that 1 minus n plus 1 divided by 2 plus n plus 1 is less than or equal to, well, actually only less than 1 minus n divided by 2 plus n plus 2 plus n. 2 plus n. Okay. Now this is so if and only if that's going to be negative n divided by 3 plus n. Who's helping me erase there? Negative n, that's 1 minus n minus 1, so it's negative n divided by 3 plus n is strictly less than 1 minus n divided by, now that's a little bit of a mess that I made there. What that should be is 2 plus n. Now this is so if and only if we can cross multiply and get a true statement. If and only if minus n times 2 plus n is less than 1 minus n divided by 3 plus n. Now let's see what we've got. In the left here we've got if and only if minus 2n minus n squared less than, I'm running out of space here, 3 plus 3 plus, that's n, that's negative 3n. So it's 3 minus 2n. 3 minus 2n minus n squared. It works. That last step, if and only if 0 is less than 3. Happiness. Because this is true, this is true, hence this is true, hence this is true, hence this is true, and we've shown that the sequence is decreasing. Now we know two things. We know that the sequence is bounded above by 0 and bounded below by -1. And we know that the sequence is decreasing. Those two facts mean we can invoke the monotone theorem sequence, the monotone theorem, and conclude that the sequence must converge to the limit -1. Okay, nice question, Mr. Naika. I'll write out the details and post it for you. So, Dr. Swartz, can we use limits as they give us the same answer? The limits will give us, so if your calculation there of the limit is fine, this question asked specifically, let me answer it this way. The way we've calculated this was to answer the specific question. But if the question says, what's the limit of this sequence? Then your calculation of just calculating limits is fine. Nothing wrong with it. Okay, I want to just go back and see the rest. The limit is -1. Yes, correct. Yes, Mr. Wu, you did the correct thing to calculate it. My mistake. Hold, it's bounded between. Yes, it still holds since A1 is 0 and the limit of the sequence is -1. Yes, that's exactly what it is, but we should have less than or equal to, right? Because for A1, the A1 is actually equal to 0. So 0 is an upper bound. It's bounded above, but it's possible for it to be less than or equal to, not just less than. I see what you're saying. That is also how I would have thought about it to do it, because -1 would be the lower bound, that's the limit of the series, since it's it, but you still needed to show that, Ms. Opperman, right? Yes, I answered that, Malobolo. I was asking if you could use the argument that since the first time in the sequence is 1, suppose we count from n equals 1. The first term, I think you meant, in the sequence is 1. Suppose we count from n equals 1 and the limit as n goes to infinity is -1, then the boundedness is minus the first term. Yes. First term is 0. Yes. Okay, so what I'll do is, this is a nice question to answer Mr. Naika's question. I'll write it out neatly. I'll put in the tick marks for where I would give marks, and I'll post it as a solution. Okay, our time is just done. So please go and work hard for your test on Saturday. Okay, either 25 or 30 marks. I'm still working on the last 5 marks. Either half an hour, either an hour or 1.5 hours. The usual rules will apply. There will be the honesty declaration that you have to complete first. I'm going to try and do that so that you can do it on Friday or Saturday morning early before the test opens, so that you don't have to waste time when your test opens. You can just download the PDF. Okay. Thanks for coming. Please tell your buddies to go and have a look at the tutorial. It's important that they go through this material. Only 30 people attended this out of 240. So please tell them to check it out. Okay, thanks for coming. We'll talk again soon. Cheers.